Let's take a look at Chapter 7 and some of the homework problems. Not just at the use of StatCrunch, but at some of the conceptual problems as well. Quite a few of you have had questions about your homework. These problems do take time, as do the problems in Chapter 8. Practice will help. Number 1 asks us to consider the concept of the confidence interval and determining the sample proportion that was started with. When you're given a confidence interval and asked about the proportion that generated that confidence interval, the easiest thing to do is to add the upper and lower bounds, in this case 0.52 and 0.68, and divide by 2. That lets you know that the originating sample proportion was exactly halfway in between those 2 points, or in this case, 0.60. The second one asks us if we have 52% of registered voters plan on voting and a margin of error is 3%, that means that you can add and subtract 3% from 52 and find out 49 to 55. Can you say with 95% confidence that he would win the election if he needs a simple majority? Think about that 49% and then click your answer. The third one asks us to interpret the confidence interval. We have a 90% confidence interval about the average birth weight in grams of all babies born last year. We can be 90% confident that the average birth weight is somewhere between 3,412 and 3,454 grams. The fourth one asks us to consider about the number of hours that students study during the week. Each of the 10 students asked 10 other students, their friends, how much they typically study. We are asked to consider if this satisfies the conditions for a confidence interval. The answer is no, because this was a convenience sample. It may not truly be representative of all college students. Number 5 gives us a confidence interval for the pizza here, for the grams, and it goes from 862 to 1028. They want to know the margin of error. The easiest way to find a margin of error if you are given a confidence interval is to take the upper and lower bounds and subtract them, then simply divide by 2. Keep in mind that your confidence interval gives you the full span, so that includes the original sample values plus your margin of error and minus your margin of error. That means the width of your confidence interval is twice your margin of error. If you subtract these and divide by 2, you will know your margin of error. Number 6 is one that is demonstrated on the other video. This is where we will use StatCrunch to determine the confidence interval. This confidence interval is determined by selecting 90% and entering the total number of P's with a number of successes being 154 yellow P's. We then also interpret the confidence interval because this confidence interval contains 25%. The true percentage could easily equal 25%. Here's one where we're asked to determine the sample size. We want to be 90% confident that the sample percentage is within 8 percentage points of the true population percentage for all sales transactions. So we're going to click on StatCrunch, and because we're dealing with proportions, we're going to choose that option in the testing. Stat, proportion, one sample. Let's determine the sample size. Confidence interval. Now we're going to return to the problem. We want to be 90% confident and we want to be within 8 percentage points. So we're going to change this to 90%. We're going to leave the target proportion at 50% because no prior data has been given to us indicating any other samples have been done. And we're going to change the width to 16% because it's 8% either way. Click compute and we get 106. That indicates that the sample size that we should use is 106, and we can go ahead and check our work. Same type of problem for problem 8, except in this particular case, we are given a p-hat from a prior study. That would mean that when we click on StatCrunch, this particular value is going to need to change. If it said 0.34, we're going to change it to 0.34. Margin of error is now 7%. Confidence interval is still 90, so we're going to change this to 14. And we're going to click compute. We're told the answer is 124. Notice that the software automatically rounds up to the nearest integer for you. If you were doing this by hand, frequently you do need to round up. Number 9, same type of problem, so we're not going to work through that one here. However, this one asks us if we had a previous estimate, like the problem we just looked at, we'll enter 0.28. If we did not have any prior estimate, then we will use the default 0.50. The next problem discusses whether or not the t or normal distribution applies. Take a look at your slide in the section in the multimedia library for Chapter 7 that has a really nice flow chart for you about which distribution applies. You want to look at criteria such as, is this a normally distributed population? Do I know sigma or don't I know sigma? Do I have a sample size greater than 30 or not? So if we look here at this particular example, the confidence interval is 95%, confidence level is 95%, n is 20, sigma is known, that's good. However, the population is very skewed. Therefore, neither the normal distribution nor the t-distribution would apply. Number 11 asks us to find a confidence interval for the mean. How do I know which type of test to use? The very fact that all I have is S indicates to me that I will need to do a t test. I will need to select a confidence interval using a t test because all I have is S, sample standard deviation. Number 12 is a similar problem. It's also a t-test, only in this particular case we are given raw data. We can simply click to open this in StatCrunch. We'll walk through this example of doing a confidence interval using t. This particular one has data, so we will click one sample with data. A lot of times we're clicking one sample with summary information from your homework problem. We're going to tell it which column to use, and we're going to double check that we get the proper confidence interval. This particular time it says 98%. So we're going to change this to 98. And we're going to click compute. Notice then you have your lower and upper limit, and you can go back to the problem, enter the data, be sure to round carefully, and then answer the appropriate questions. The next problem asks us to determine the sample size to satisfy this particular research. How many computer users must be surveyed in order to be 95% sure that your sample is within 11 minutes of the population mean? The standard deviation of the population is 226 minutes. Because it gives us the standard deviation of the population, we can use the normal distribution or the z-test. So we'll click to open StatCrunch, and we will select z-stats, one sample, and try to determine the sample size. So again, we're going to click confidence interval width. Let's see what we can enter here. 95% within 11 minutes, and we have a standard deviation of 226. So we're going to put 226. Within 11 minutes, the margin of error means 11 minutes up, 11 minutes down for a total of 22 minutes. And we're going to click compute, and we would have to survey 1,622 people. The reason that is so large is because our standard deviation is 226 minutes. That's a fairly substantial standard deviation. So we enter our sample size, and then we can answer the subsequent question. Number 14 asks us to also compute a confidence interval for the mean. Again, this particular time we need to look at the problem and ask ourselves, do we or don't we have a population standard deviation? In this particular case, we are given the population standard deviation, sigma. So when we would click on StatCrunch, we would use Z statistics, and we would go here, enter our mean, standard deviation, and sample size. So let's take a look at that for this problem. We have the sample mean is 35.56. The standard deviation is 10.9. And the sample size was 141. We are trying to determine the 99% confidence interval. We're going to go ahead and click compute. And we can see that it's from 31.1955 to 37.92. We check, it says to round to 2 decimal places. So let's see, 33.20 to 37.92. 37.92. Again, be careful how you round, and then answer the appropriate question about the concept. This particular one says, notice the confidence interval limits do not go below 20 years, do not include ages below 20. What does that mean? Does that indicate that motorcyclists under the age of 20 never die in crashes? Not at all. It simply means that the average age is between 33.2 and 37.92. So we could say that the mean age will most likely not be less than 20 years old. Oh, no, we want to think about that again. Wait, look what I clicked. I clicked sample. Make sure that you choose population. Remember that the confidence interval is talking about the population. Good point to think about when I'm doing my homework. That's a mistake that students frequently make. Number 15. What's different on number 15? In number 15, you are asked to find a confidence interval for the population standard deviation. Number 16, similar type of problem. Find a confidence interval for the standard deviation. Keep in mind when you click to find a confidence interval of a standard deviation that when you select your variance test, you will need to square the standard deviation. So we're going to choose variance stats, and we're going to take a look at this test. Okay, so let's see, sample variance. Well, the sample standard deviation was 0.65, so 0.65 times 0.65 is 0.4225. Sample size is 103. Our confidence interval is supposed to be 98%, and we're going to click compute. So now the temptation is to assume that we are entirely finished. We want to be very careful with that because it's asking me for the confidence interval for standard deviation, not variance. The computer software gives me the confidence interval for the variance, so I can either go to my program server, pull up my calculator, or pull a calculator out of the bag, but I'm going to need to take the square roots of both of these values in order to enter my standard deviation. So again, let's take our calculators out. We're going to type in the square root of 0.3119781, and the computer asked me to round to 2 decimal places. So that would be 0.56, and then the square root of 0.600, 0.78. So again, I need to take the square root of both of those, check my answer. Please be careful with your rounding. That is a common place for students to make errors. And then go on to answer the concept questions. The next problem, same thing. Confidence interval for the standard deviation of body temperatures. Here's one we're finding a confidence interval for standard deviation. This one has raw data instead of summary data. And the last question simply asks us to read the chart and determine the appropriate sample size. I hope you find that helpful. Good luck. On to Chapter 8.